Hello everyone, welcome back to my channel Learning Fundamentals by Ankit Shukla. I hope you're all doing well. This is part 1 of the chapter 2 for Networking Fundamental series. Today we are going to learn about the IP addresses and classes of IP addresses. If you haven't watched the chapter 1 of this session, please go to the description of the session below or subscribe to this channel and check the session 1 of the series. Let's get started with the session. All right, guys, this is chapter 2 of the learning fundamentals. As I explained in the introduction, we are going to talk about the IP addresses, the classes, the IP subnet, the subnet mask, and the networking devices. So first on the list for this session would be IP address classes. IP addresses are essential for identifying and communicating between devices on a network. They are like unique postal addresses for devices in a network. Here's a breakdown of how and what IP addresses are and what different classes they come in. Uh, as I explained, an IP, which is Internet Protocol Address, is a numerical label assigned to each device connected to a network that uses the Internet Protocol for communication. It serves two main functions. First one, identification, which means it identifies the network. It identifies the device on the network. Then it talks about the second part, which is the location addressing, which is to provide the location of the device on the internet or the network so that data can be sent to and from it. An IP address is a series of numbers separated by dots. It looks something like 192.168.1.1. It's a 32-digit number divided into 8-bit sections called octets. So there are 4 octets, 8-bit sections, and 32-bit number, which means each octet has 8 bits. And each octet can range from 0 to 255. So, and as an example, if you see this IP address 192.168.1.1, it has 32 bits, which means it has 4 octets: 192, 168, 1.1. So 192 represents one octet, 168 represents the second octet, and similarly 1 and 1 represent two other octets. Altogether, they make up 4 octets in an IP address. Each octet has 8 bits, irrespective if it is a 3-digit IP, 2-digit IP, or the class as in 192 it has 3 numbers, it still has 8 bits. Similarly for 168, it has 3 numbers, but it has 8 bits. Similarly for 1 and 1 as well. So altogether 32 bits, 8 bits on each section, and each section is called as octet. Next, if you look at this diagram, it talks about the IP address formats. IPv4 and IPv6 are the two commonly types of IP address. Most commonly, IPv4 is still used in the market or in the global world. IPv4 consists of 4 decimal numbers separated by periods. Each number is between 0 and 255. On the other hand, IPv6 addresses are longer and are written in hexadecimal format, separated by colons. They provide a larger address space than IPv4. Just so you know, IPv6 is used in modern devices, in modern technology. You can say from past 5 or 7 years, it has been in use. But still, in the world, we still are heavily dependent on IPv4 addresses. In the diagram, you can see on the right hand side, there are multiple IP addresses that you can label. They are in different classes, and on the left hand side you can see the diagram that I explained in the chapter 1, like public IP address, private, static, and dynamic. Next up is the IP address and its classes. So IP addresses come in different classes to accommodate various sizes and types of networks. Each class has a specific range and default subnet mask, determining the number of devices that can be addressed within the network. Understanding these classes helps in designing and managing the network infrastructure effectively. There are 5 classes of IP address: class A, class B, class C, class D, and class E. Let's look at how these classes look like. If you see in the next page, it says it looks like a schematic representation of how the IP addresses is divided into classes or its subjective range. IP addresses in whatever classes have a network portion and a host portion. Each portion represents an octet, meaning we have 4 octets in an IP address with a combination of 1 or 3 network and host portions. We'll talk about that in the later part of this video. Each octet represents 8 bits and hence an IP address is of 32 bits. If you see in this diagram, it says class A, class B, class C, class D, class E. The starting range of class A is 0.0.0.0 to 127.255.255.255. That's the range of class A, and similarly for class B, C, D, and E. Next, we are going to take a closer look at Class A IP addresses in the world of computer networks or digital world. Class A IP addresses are designed for very large networks with a massive number of hosts. They are identified by their leading bit pattern and a specific range of addresses. They have a subnet mask. The default subnet mask for Class A is 255.0.0.0, which indicates that the first 8 bits are used for the network portion, while the remaining 24 bits, the remaining 3 octets, are available for the host address. Number of networks and hosts that can be there in a Class A IP address would be 128 for networks, basically from 1 to 126 with the first bit set to 0. And then the host can be up to 16 million and above. Due to their large number of available host address in Class A networks, they are typically used by very large organizations, or you can say internet service providers or corporations with a very extensive infrastructure. Let's say for organizations which have a broad exposure across the globe. For let's say a university which is based out of different geographies, they may have different set of IP addresses, and that's where Class A IP address is reasonable and uh, perfect for them, wherein they can expose their network or have multiple and huge sets of devices which they need to address and connect to the network, and that's where Class A IP address is absolutely perfect for them. The advantages of Class A IP address are that they are highly scalable, because with millions of possible host addresses within a Class A network, it can accommodate a vast number of devices, making them ideal for large organizations. The second advantage we have with Class A IP is the simplicity, because the default subnet mask of Class A IP, as I explained earlier, is 255.0.0.0. It simplifies the network configuration and the management. In short, Class A IP addresses are a critical part of the IP address hierarchy, which are designed to support the largest and most complex networks. They provide the scalability and simplicity needed to manage extensive networks and their environments effectively. As you can see in this example, we have 2 IP addresses, 12.0.0.1 and 100.10.12.3. The first octet in both of them, let's say for the first one, it is 12. It represents the network portion, and the remaining 3 octets like 0.0.1, they represent the host portion. Similarly, for the other IP address in this example, 100.10.12.13, 100 represents the network portion, and the remaining 3 octets, that is 10.12.13, they represent the host portion. Now we move on to Class B IP addresses. They are designed for medium-sized networks and offer a balance between the number of available networks and the number of hosts per network. Here's a detailed lookup at the Class B IP addresses. They have a network range from 128.0.0.0 to 191.255.255.255. Example of a Class B IP would be 172.16.0.1. It's a Class B IP address. The subnet mask for this Class B IP address is 255.255.0.0, which means it had 2 octet for the network portions and the 2 remaining octets for the host portion. You can think of an university with multiple departments and buildings. A Class B IP address could serve the needs for a similar kind of departments or a building or a university in a better way, but compared to a Class A, which means an organization which is not that big, but yes, they still need multiple range of IP addresses. They also have a global exposure, but not are as big, or they don't have no more, number of devices as huge in count compared to a Class A IP. If you look at this diagram carefully, the network and host portion in this piece, this is a Class B IP. So the network portion, the first two octets, as I explained, 16 bits, each octet is 8 bits. So two octets over here are dedicated towards the network portion, and the remaining two octets are for the host portion. Again, 16 bits for the network, 16 bits for the host. Number of networks that can be there in a Class B IP is 2 to the power of 14, that is 16,000 plus approximately 16,384 networks, and the number of hosts per network would be 2 to the power of 16 minus 2, which is 65,534. So in short, number of networks that can be there in a Class B IP is 16,384, and the number of hosts per network would be 65,534. In this diagram, you can clearly see there are two IP addresses, one at the top, one at the bottom. The first two octets, for the first one, that is 130.11, that represents the network portion, and the remaining two, 12.30, that represents the host portion. Similarly for the other IP address as well. All right, now we move on to Class C IP addresses, which are commonly used for the small networks like those found in small businesses or home environments. They provide a large number of individual networks with a relatively small number of hosts per network. Class C IP address has an address range from 192.0.0.0 to 223.255.255.255. The default subnet mask is 255.255.255.0. This means that the first 24 bits, which means a 3 octet at the beginning, are the IP address which is used for the network portion, and the last 8 bit, or you can say the last octet, is used for the host within the network. The number of networks and hosts vary drastically, or they are very less compared to Class B or Class A. The number of networks in Class C would be approximately 2 millions. It's actually more than that slightly. Then the number of hosts per networks would be 254. All right, this is a schematic diagram of a Class C IP address. The first three octets, as I explained in the previous 10 seconds back, they are dedicated towards the network portion. So basically meaning the first three octets are dedicated for the network portion. The last octet, 101, as you can see in this diagram, is dedicated towards the host portion. And the other example, you can see that as well, 210.55.10, that represents the network portion of this IP address, Class C. And the last one, which is 105, the last octet of this IP address, that represents the host portion. All right, now we move on to Class D IP addresses. The Class D IP addresses are used in multicast applications wherein data is transmitted to multiple devices simultaneously. This is a commonly used IP address class in streaming media, online gaming, stock markets, financial feeds, video conferencing. This video right over here, this is actually recorded on a Class C network. However, when it is transported over a video, or you can say passed on or transcribed to a video, it goes through a Class D IP address. Examples of a Class D IP address are, first we have to talk about the ranges. The ranges are 224.0.0.0 to 239.255.255.255. The example could be 239.192.0.1. This is a Class D address because The first octet 239 falls within the class D range. The class D range here is 224 to 239. This address would be used to identify a multicast group rather than a specific device. Basically, these are identified through a multicast group channel rather than a specific individual device. The advantages of a class D IP address is that it can multicast. It is because of multicasting, it is more efficient, right? And it reduces the network bandwidth usage by sending a single stream of data to multiple recipients. It's like multicasting your information towards multiple recipients rather than separate streams, or dedicatedly transferring the data to individual hosts. It is highly scalable. It allows for scalability, or you can say a delivery of content to many users without even any impact to the network or the bandwidth. In short, you can say that the class D IP addresses are vital for multicast communications, enabling the efficient and scalable data distribution to multiple recipients. They play a very crucial role in applications where simultaneous data delivery to many users is required. Think of that as an example of a soccer match which is live telecasted. That's an example of a class D IP address. There is no subnetting as well in class D IP address. The last class in the classes of IP is class E IP address. The class E IP address example would be 250.1.1.1. Their address range starts from 240 to 255, basically in precise 240.0.0.0 to 255.255.255.254. Why we have class E IP address? These are typically used for testing or experimental or research and development within a very closed or secure or maybe confidential environment. The advantages of class E IP addresses are that they are used for future proofing because they provide a reserve IP range for potential application testing or development. Then for research and development, they are highly useful. These addresses are available for testing new protocols. Anything that you see in future or you hear about it, understand it that there has been a lot of work or testing done on that application or that product, but that is happening on a class E IP address. In short, you can say that the class E IP addresses are reserved for experimental use and future needs, offering flexibility and the potential for innovation in the network research. They play a very crucial role in allowing the exploration of new technologies without impacting the existing IP address space. When we talk about the classes of the IP addresses, basically IP addresses come in different classes to accommodate various sizes, types of networks. Each class has a specific range and a default subnet mask, as I explained, determining the number of devices that can be addressed within the network. Understanding these classes actually helps in designing and managing the network infrastructure effectively.